All right, so continuing through some vocabulary here. All right, so let's define things. Remember what we talked about? Bases. Bases on a prism are parallel and congruent. Okay? Turns out it's the same thing here. And clearly the cylinder are kind of like prisms, just where the bases are circles. So clearly these two are my bases, here and here. All right, radius, don't really need to define that. You already know it goes from the center to the edge of the circle. And that would be your radius, like so. And the altitude. Altitude here is the same definition as prism. It's the distance between the bases. So altitude is not up and down. It's distance between the bases. So find the bases first, and that helps you find everything else. Everything else. So in this case, this is going to be my altitude. We'll call it A for altitude. And in this one over here, the distance between the bases is right here. That's my altitude. Notice that this is not my altitude because of the slant. That's not my altitude. That actually has a name. That is called the axis. Why? Because it goes from center to center. Same thing over here. Center to center is called my axis. Now it turns out that your axis could be the size of your altitude, but not always the case. Center to center. And learn to spell. So, both of these are two types of cylinders. This one here is called a right cylinder. And the reason for that is because the radius and the axis have a right angle. This one over here is called an oblique because it is leaning in some capacity. Cylinder. And the reason for that is because the angle with the axis there is not 90. The axis and a radius is not 90. One small change in the cone here. Clearly it's not bases, it's just base. And on a cone, the base is always a circle. So we know the radius there. The altitude always goes from the vertex. It goes from the vertex to the base, and it has to be perpendicular. Has to be perpendicular. So here's my vertex. And in this case, to get to my base, it meets at the center nicely, and it's right angle. However, this guy here, this drops down, like I drop a rock there, and it lands on the same plane as the base, but clearly it doesn't even touch the base. So this one right here is my altitude there and there. So the altitudes do not have to even touch the base, they just have to be in the same plane as the base. Again, it's from the vertex, and we say down, but it doesn't have to really be down. All right, again, this one's called oblique because of the lean. And this one is called right for the same reason as before. And these are cones. The vertex, notice it only has one vertex, just like the pyramid, the vertex of the pyramid. And this one has the vertex of the cone. And since there are no other vertices here, there aren't any corners at all because of the circle. There's only one vertex, so there's no confusion. All right, and the last thing we're going to chat about is spheres. Clearly, there's a center. Now, a sphere is a circle but three-dimensional, right? The definition of a circle says it's the set of all points, that point, that point, that point, that point, that point, that point, that is equidistant from another point. So here, you don't have to draw this. This here would be the set of all points all the way around, that's equidistant from the center. And so we end up getting this circle. Well, we're doing the exact same thing, but this time we're going to go up and out and inside and off the page such that we have a three-dimensional. So we go all the way across to and over, so three-dimensional. And a great circle is the largest circle on the sphere. Now, there's not only one of them, there's an infinite number of them. So, for example, this is not a great circle. If I try to connect this to this and I go around like that, that is not a great circle because it's a small one compared to this one. This one, of course, goes around like that, as does this other one that's horizontal. That one goes around like that. So the key thing is, notice the great circles all have the center as their center. So great circles and spheres have the same center. The largest circle on the sphere, and it has same center as the sphere.